All right, so there's one more problem on the back of this page that I want to talk about a little bit as well. And that's this one where we're taking a diene and reacting with HCl under cold or warm conditions. We talked about adding HX groups across a diene, and I want to go into some of the details on this particular one. In any of these problems, you want to start off by trying to figure out what the most stable carbocation intermediate is going to be. So in this case, if I treat this with, HCl, it doesn't matter if it's warm or it's cold, we want to try to form the most stable carbocation that we can. So that's our first thing, form the most stable carbocation. So that means that we're going to protonate this in such a way that we're forming a resonance stabilized cation. There's actually two different ways that we can do that in this particular case. In one case, we can add a proton to this terminal carbon here. That is going to give us a proton there. And this carbocation has a resonance structure that can be drawn. That looks like this. Let me scoot that down so we can see. So we protonate this terminal carbon, and we end up with a tertiary carbocation that has a resonance structure where we're sharing that positive charge with a secondary center. The other option is to protonate this position. So the purple route versus the blue route. And if we do that, put the hydrogen here, and we have a carbocation here. This is a secondary position. Its resonance structure looks like this. So the second case, we're sharing the carbocation between a secondary and a primary carbon. The first one, we're sharing between a tertiary and a secondary. I like the first one a lot better. This is a more stable carbocation. That's the one that we want to use. So now that we have that carbocation there, if we are running this reaction at 0 degrees, meaning this is the kinetic product, that chloride that's in solution is going to attack that carbocation, which is proximal to where we added that hydrogen. So that means the product in the end is going to look like this. Okay. If we run this reaction at 50 degrees, then we need to consider both of the resonance structures that we can draw for that carbocation. Here we have a tertiary, here we have a secondary, but more importantly, here we have a tri-substituted alkene. So it's the alkene stability which is going to be important in this case. So we go for the more stable alkene. Thermodynamically, that's going to be the favorable outcome, which means the chlorine is going to attach to this position. So a hydrogen was added at the 1 position, and now the chlorine is added at that 4 position. So when you do these types of problems, the first thing you want to do, try to form the more stable carbocation that you can get. From that carbocation, you do the 1,2 addition product to get to the kinetic product. And then for the thermodynamic product, you really have to look at the alkene stability. 1,4 or 1,2. Look at that alkene stability. That's going to tell you which one is which. It's typically 1,4, but it's not always going to be 1,4. So hopefully this information is useful as you try to solve these types of diene addition problems.